Hello, in this video we're going to look at continuity and specifically look at continuity looking at a graph. So for a function to be continuous, we have to have these three criteria. We have to have the limit as x approaches a for our function has to exist. And that means that the limit from the left and the limit from the right have to be approaching the same value. And that value does need to be a finite number. So we can't have both ends going to positive infinity or something like that. It has to be a finite number. The second criteria is that our function has to be defined. F of a can't be a hole in our graph or cannot be an asymptote or something like that. Our function has to be a finite number. And then the third criteria are that those two numbers are the same. The limit can exist and the function can be defined, but it won't be continuous unless those are both the same number. All right, so let's look at a graph here. All right, we can use our basic algebra approach to a graph is continuous if we can draw it without picking up our pencil. And we will see that we're going to have four main issues here. We've got one issue here at x equal -3. We've got an issue here at x equals 0. We have an issue here at x equal +3. And we have an issue here at x equal 4. So there's four places where our graph is discontinuous. So now let's go and look and apply those criterion above to see why. So the first thing we need to do is identify the limit. So first we'll look at that first one there on the left, x equal -3. So we're looking at this point right here. So x equal -3 as we approach from the left and from the right for our function f of x that's graphed here in blue, we do see that from the left it's approaching a y value of 1, and from the right it's also approaching a y value of 1. Since those are the same, we do have that the limit as x approaches 3 in general is equal to 1, so that is a finite number. So we're good on criteria 1. But when we go to criteria 2, at least as far as what we can see on this graph, there is no point. We have an open circle here at x equal -3, but we have no closed circle where x is equal to -3. So that means that f of -3 is undefined, and that is the criteria that is violated for continuity at that point. Okay, let's do the same thing for x equals 0. If we approach the limit as x approaches 0 from the left, we see that from the left our graph is approaching a y value of 0, and as we approach from the right, our graph is approaching a y value of 3, and these are different. That means that the limit as x approaches 0 in general does not exist. And so that would be the criteria that would be violated at that point where x is equal to 0. All right, now let's look at this point here at x equal +3. So when x is equal to +3, we see that the limit as x approaches 3 from the left of our function, from the left, our line as we approach 3 is getting closer and closer to a y value of 2. The limit as x approaches 3 from the right of our function Our line that's getting closer to 3 is also approaching 2. Those are the same. So that means that the limit as x approaches 3 in general for our function is equal to 2. So that's a finite number. So we can check off that first criteria. F of 2, well, we have an open circle here, but we do have a closed circle down here at a y value of -1. So that's a finite number. But the problem is that those are not the same. So this would be the third criteria that would be violated. The limit as x approaches, oh, that should be 3, not 2 there. As x approaches 3 for our function is not equal to f of 3. So the third criteria is the one that is violated when x is equal to 3. And then our last one is where x is equal to 4. So when x is equal to 4, we see that the limit as x approaches 4 from the left, if we're on the left side of our function, this is going up, that's going to positive infinity, and we can really stop right there because we know that that is going to mean that the limit as x approaches 4 in general at least is not a finite number. And so that first criteria is the one. We can see that the left is going to negative infinity, but it does not matter because it's not a finite number. We have to, those limits have to be approaching finite numbers for us to even talk about the rest of it. All right, hopefully this clears up a little bit on looking at a graph and determining the continuity. I'll see you guys next time.